Okay, yes, you are seeing the screen. All right. So last week we didn't have time to do this extra question. So can we quickly go through this? It's just one question and then we will be on to our today's worksheet. All right. So here is saying a scientist performed an experiment on a fixed mass of gas. So we are talking about a gas here. So inside a container. So this gas is kept inside a container and this scientist is interested to find the relationship between pressure and temperature. That means pressure of gas and temperature of gas. So she got the results. So you notice that over here, as pressure go up, all right, as pressure go up, what happens to temperature? Can everybody let me know? So I'm gonna let this be T, I'm gonna let this be P. So as P increases, can everybody type into the chat what happens to temperature? Looking at the graph. All right, 10 seconds for everybody to tell me, up or down or remains the same. Increases, decreases, or stays the same. All right, then looking at the graph, tell me this one. Increases, decreases, or stay the same. 10, 9, 8, 7, 6, increases, decreases, or stay the same. What is in the box? Okay, thank you, Larissa. Thank you, Saron. Actually, well done, two of you. The rest, can I have a response, please? Thank you very much. So at least I know whether you understand. It's okay to give Miss Ivy the wrong answer. All right, we are all here to learn from each other. Okay, so the rest, what is your answer? Danish, would you like to try? I saw your answer. Well done, you're right. Okay, Kiran, what's your answer? Zenith as well. And Levon, where's the answer? As pressure goes up, right? As pressure increases, what happens to the temperature? All right, does the temperature increase or decrease or stay the same? All right, so you can see from the graph that the pressure is going, right, it's going up. So you see, for example, if the pressure is 140, if this pressure is 140, and then temperature will be 450. Then if I go up to 180, if the pressure goes up to 180, touch the graph and go to the left. All right, this over here, so it's about 600. All right, so you see that as you can actually see from here. Okay, just a minute. There's a window that is blocking your. Okay, fine. All right, so when the pressure is 140, all right, touch the graph, go to the left, the temperature is 450. Then when I bring up the pressure to 180, means 140 go up to 180, that's for pressure. As pressure go up, you look at the temperature also go up. 450 go up to 600. All right, so here is go up. Okay, so as pressure of the gas increases, temperature of the gas also increases. All right, good job, Zenith. Okay, so this is how you read the graph. The graph is very simple. You can see that the graph is going up, climbing upward, going up. So that means as pressure goes up, temperature also goes up. All right, and everybody try and give me the answer A, B, C, or D. Now, obviously, decrease is obviously wrong already, right? All right. So because as temperature go up, pressure go up. So increases is correct. Just a minute. All right, so increases is correct. So the answer is between C and D. All right, so because as temperature goes up, pressure also goes up. So if temperature goes up, that means you're supplying heat, right? Heat is supplied. All right, you're heating it up. So when temperature goes up, that's the meaning of heat is supplied. Pressure will go up. But here they say pressure go down, which is wrong. All right, pressure go down is wrong. So pressure should go up, pressure should go up. So what is the explanation? All right, well done, Larissa. Okay, so why is it that when you heat up the gas, when you heat up the gas, the pressure of the gas go up? All right, so is the answer C or D? Okay, can you rename yourself selling kits? All right, thank you. So everybody type your answer, C or D. How do you explain that when I heat up a gas, all right, the temperature obviously will go up when I heat up the gas. And why is it that the pressure of the gas also go up? Okay, well done, Saron. The rest? Okay, well done, Zenith. Okay, so it's because the particles of the gas will hit the wall more often. So there's a comparing word here, more often. So the answer is D. All right, so I hope this helps everyone. Okay, so I'm going to change the slides now. Selling kits on eBay. Can you rename yourself, please? Thank you. Okay, let's start for today's worksheet. All right, so again, this is the usual rules. So do feel free to use the chat if you have any question to ask, or if you don't understand, please don't just type I don't understand. Or if I'm going too fast, please give me feedback. All right, if going too slow, also give me feedback via the chat. Okay, so National Day promotion, I mentioned this before. So please continue to share with your family and friends. Give them the handphone number and your referral code that is sent to your parent SMS. They get 25% off. You also get 25% off if your friend chooses to subscribe. If your friend doesn't choose to subscribe, they still have one free live lesson. All right, let's start. Question 1. This is one molecule. Can you see that it is one big molecule? It's like a family. Now, molecule is like a family. All right, so molecule is like family, but please don't write family in the exam. So I use inverted comma, like family. It is an analogy to help you remember the idea, okay? So imagine this is like father, this one mother, all right, and then you have child 1, child 2, child 3, child 4, child 5, child 6, child 7, 7 children. It's one big family, all right? So this is called one molecule, all right? So what I'm circling is one molecule. So looking at this, right, okay? First of all, I would like to praise 2 of you. There are 2 of you. Let me just go to my Excel file. All right. Kieran and Yujie. All right. Now Kieran is here. Yujie is still not here. Now Kieran and Yujie have already tried this online worksheet. All right. However, the rest, I don't have answers from you. Could I understand from everyone what is stopping you all from doing the worksheet? Can you please type in the chat? Of course, Danish, you don't have to reply because I'm not sure whether you can have access to this worksheet, Danish. Not sure. All right, but can I understand everyone's situation? Is it because you're too busy with your homework, too busy with enrichment activities, or is it because you cannot access the portal and you cannot see the worksheet, or you forgot to do? Really, your honest feedback so that we know what is going on. Because out of this class, only 2 students have attempted the worksheet 31. So I just want to find out more. Your honest reply. Thank you, Chen Xin. I like your honest reply. At least I know what's going on. All right. I will share Chen Xin's reply later. Okay, thank you, Zenith. Okay, Larissa. Okay, no worries. All right, so at least I know what is going on in your life. All right. So really your honest reply. All right. So my concern is as a tuition teacher is that, if you don't have time to do, I will not be able to see which questions are the ones that most of you find it challenging. Right. So for example, thanks to Kieran and thanks to Yujie, I can see that question 3 and question 6 are problems for the class. All right. So I can give more emphasis on the 2 questions. Okay. Now let me go back to the just make a quick attendance for one of you. Just a minute. All right, let's continue. Let me see if you're looking at what I'm looking at. Yes, you're still looking at that screen. Right, let's start. So over here, this is quite simple. Most of you get it right. So this is ethanol. So just for interest sake, all right, ethanol is if you have beer would be about 4 to 5% ethanol. Okay. Then if you are drinking wine, be it white wine, red wine, Do y'all know how many percent ethanol? Anybody knows? Please don't drink alcohol. You're not at the age to drink alcohol, but you can have some general knowledge that beer is 4 to 5% ethanol inside. Anybody knows? Make a wild guess. How much percentage ethanol is inside wine? Red wine, white wine. If you drink a wine regularly, not too much, all right, it's actually quite good for the body. Thank you, Sir Ron, for guessing. All right, the rest, you want to make a wild guess? And then we have XO or whiskey. Right, so wine is about 12% or so. XO is about 40%. All right, so in other words, if you drink a little bit of XO, you can easily get drunk because there's more ethanol. Now, nobody will sell you 100% ethanol. You want to drink 100% ethanol? Can, but you'll be in heaven after drinking it. So it will kill. So we do not drink 100% ethanol, all right, because it's poisonous to the body. All right, so XO whiskey about 40% is already considered quite high already. Okay, so coming back to this one molecule of ethanol, all right, there are many types of alcohol in the world. So we have methanol, we have ethanol. Do you see? And then we have propanol. All right. So there are many. I just want, you don't need to remember the names right now. All right. However, this one you will need it in Set 4. However, I just want you to at least know that there are many types of alcohol in the world. Okay, so ethanol is only one type. All right. Then maybe I will help you the memory aid, which you will find useful when you go up to Set 4. All right, so Mary eats peanut butter. All right, so the memory aid is Mary eats peanut butter. So it helps you to remember the first letter. All right, so methanol, ethanol, propanol, butanol. Because you will have other chemicals called methane, ethane, propane, butane. All right, you will have methanoic acid, ethanoic acid, propanoic acid, butanoic acid. So it's always MEPB. All right, the first letter. Okay. So anyway, I'm going be slightly beyond, just letting you know you can remember it by Mary eats peanut butter. You know, peanut butter jam. All right. So back to this ethanol, which is one type of alcohol. So this is carbon. So how many carbons are there? So there's obviously 2 carbon. All right, so this is 2 carbon. Then hydrogen, I have 1, 2, 3, 4, 5. Now I have 5 here. I know this is another hydrogen. This is an oxygen. This whole part, right, I'll put it as OH. All right. So all the alcohol at the back has an OH. So in other words, there are six oxygen. But the way we write it, instead of 6 hydrogen, it is 5H, and then we put a H behind. So all alcohol at the back has an OH. It's like the surname of alcohol. All right. So like if your surname, your family surname is Lim, your name will have a Lim. Your brothers and sisters will have the name Lim. Your father, you will also have the name Lim. Okay, so same thing, all the alcohol has a certain surname, all OH at the back. So methanol, ethanol, propanol, butanol, formula at the end is all OH. I used to have a teacher called Mrs. O. Mrs. Shirley O. Her surname is O. All right, but sadly, she has passed away already. Okay, so because of cancer. All right, which is very sad. I do miss her. So anyway, OH is the like a back part. All right, part of the molecule of all alcohols. So all alcohols behind is OH. In terms of spelling, is OL, 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 OL. All right, but the formula is 1 O, 1 oxygen, and 1 hydrogen at the back this way. All right, so I've given you more pictures. So when I went to university, I went to buy this molecular set and to create all the molecules when I was studying university chemistry, right? Because the molecules get more and more complicated, I couldn't visualize it in my mind because when I was in university, there was not much of an internet, or rather, we really don't have like Wikipedia, we don't have Google at that time. So we couldn't Google for the information. Okay, so we have to use all this to build the molecules on our own. So the black color stands for carbon atom. The white one stands for hydrogen atoms. Then oxygen is